You've read the rules, you've created your strategies, you've put in the time, you've done the math. Now it's time to show us what you've got. Welcome to this week's episode of FMA Plus.
Welcome back for week 12 of FMA Plus, our final week of team coverage for the 2020 season. Of course, next week will be our final awards show for the 2020 season. Tonight, though, we've got Team 423, the Simple Machines from Wyncote, Pennsylvania. Got Team 2600, Team Falcon from Oak Ridge, New Jersey. And Team 303, the Test Team from Bridgewater, New Jersey.
All right, so I'm here with Team 423, Simple Machines out of Wyncote, Pennsylvania. Super excited to hear from this team. And with that, Venus, I'm going to tee it off to you. Why don't you introduce us to your team?
Hi, this is Team 423, Simple Machines. This is our 20th anniversary, and we're so excited to be here today.
We're certainly glad to have you. I'd love to get a chance to meet you all and learn about what you do on your team.
Hi, my name is Venus. I'm a junior, and I am co-captain of the team.
Hi, my name is Owen. I'm a junior, and I'm co-captain of the team.
Hi, I'm Jagu. I'm also a junior, and I'm design team lead.
I am Ryan. I am a graduate from the team and a former captain.
And I am Joshua, and I'm an engineering mentor who has first competition t-shirts that are older than all of my teammates.
I know how that feels for sure, Joshua. I sympathize with you there. All right, guys. Well, it's great to meet you. With that, Joshua, let's talk about team mottos. So one of the questions you had here is, what knowledge has a veteran team acquired over 20 years of building robots that can benefit younger and rookie teams or even new members of your team?
I'll ask our team. Team 423 Simple Machines, what is engineering?
It's
Choosing.
Engineering is choosing has become a team motto. This is not an answer I would have been able to give you right out of engineering school. Working as an engineering mentor with FRC teams for the first decade of my career allowed me to hone this message to help students frame their purpose and role as engineers. We accept that all choices have consequences. Some are good, others are negative. Consequences can also be intentional or unintentional, independent of their pros and cons. The key to our approach is ordering our priorities so that during the engineering analysis, design, build cycle, we have a framework for making choices. The hard part is understanding how the pros and cons associated with your choices can change as your priorities change. Another lesson we learned the hard way is the basis for another team motto: failure is not an option, it's a requirement. It's specifically written or said that way because most people are familiar with the first half of the expression, which is typically used to inspire people to achieve seemingly impossible things. As people, we know that failure is inevitable and it's a part of life. But as engineers, we can make choices to mitigate and learn from failure as part of our culture.
I think it's really interesting to sort of hear the perspective on developing team culture as well. So Owen, I'd love to hear from students here. What does it mean for failure to be a requirement?
So at the beginning of the build season, we usually make a schedule and have deadlines to complete tasks, but we make sure to incorporate extra time for failing and improving because we usually learn the most from our failures. If we have time to fail, we usually end up with a mechanism that survives competitions and performs better, and we can use this information we gain from our failures to improve in the future. One example of us planning for failure is how our drivetrain design is held in place with 2 bolts on each side. So if one fails, it is very easy to drop it out and replace it. At competitions, it's very common for something to fail or break. So when this happens, we usually make a note of how and why it failed, start thinking of possibilities to improve the part after the competition, and then fix it as much as possible before our next matches.
Nice. Yeah. Jal, let me ask you, how did those mottos get applied to building this year's robot specifically?
Yeah, so the mottos that Joshua and Owen said, for example, engineering is choosing, helps us go about designing. So when we think of designing, we have to go and think about the consequences of each decision, and we balance those against Joshua's laws of robotics, which are number 1, drive reliably, number 2, do at least one scoring task repeatedly, number 3, participate in the end game, and number 4, be prepared for inexplicable dancing. Now, Joshua's laws give us more focus on what to prioritize. So when we're in the early stage of planning, we look to Joshua's laws of robotics to narrow down which ideas to pursue.
I love hearing about the structures for decision making that different teams make. So thank you for kind of giving us insight into yours. Now let's start with this year's robot, of course, from the ground up, as we typically do. Ryan, what was your solution for driving reliably, and is it different from typical FRC solutions?
So this is our second year of doing our custom design for our drive system. Last year we used version 1 of our bogie drivetrain, and this year we used version 2 of our bogie drivetrain. We use a combination of off-the-shelf parts and design choices that yield a custom solution. The bogie drivetrain design is a 4-bolt droppable drivetrain where you take 4 bolts out and you can drop it off the chassis. So you can work on each individual side independently. The drivetrain is made from a laser cut sheet metal and CNC press brake folding. We use aluminum sheets to create our lightweight design. The design allows for different configurations after fabrication if the overall chassis design needs the different configurations. It is able to change between a 4-wheel or 6-wheel design, and it allows it to be universal depending on where the motor is mounted. We use belts for easy tensioning. We are using the Evo shifters for the first year and allows us to have better control over the robot. Each drivetrain bogie weighs just over 10 pounds with motors and gearboxes, and the entire drivetrain and chassis weighed 32 pounds.
Nice. So, Owen, let's talk about scoring. What was the plan for scoring repeatedly this year?
Our plan for scoring repeatedly was to have a shooter that went down to the ground to pick up power cells, stored them behind the flywheels, sped up the flywheels, aim at the goal, and then use a conveyor to push the power cells into the flywheels. Our shooter had a way to adjust both the speed of the flywheels and the angle it gets shot at. So we had multiple ways to adjust our shots in the heat of matches. Also, the shooter was able to pick up off the ground, the loading station, and shoot at all 3 goals. Later in the season, we decided to add a mechanism that made picking up power cells easy. Our requirements for it were that it had to be light and it had to be able to drop out past the bumper to grab the balls and move them to the shooter. Although there were some challenges with mounting the intake because so many things were changing on the robot at the time and we had to improvise a mount, we were able to create an intake that would drop down, center the power cell with mechanism wheels, and then push it into the flywheels of the shooter. Luckily, it did not break at the competition and was very good at what it was designed to do and greatly assisted our pickup speed. If we still had access to the lab, we would probably be making the design more rigid in case someone was playing defense on us, and we would make the wheel placement more efficient to center balls faster.
So let's talk about endgame. How did you guys participate in the endgame, and what did you feel was most unique about your solution?
Yeah, so we used a one-stage elevator, which allowed us to climb when the scale was at its lowest and middle positions. We used a commercial prismatic linear guideway, which was chosen after weight analysis and load testing. Now, these prismatic rails capture the carriage blocks in all directions while allowing them to slide smoothly while under load. The guideways are also hard in steel that are heavy, which is probably why we've never used them before. But the prismatic rails give us the most travel distance because it's supported in the back so that the carriage blocks can travel the entire length. We had a very successful lift and having one of the most successful lifts in competition.
All right, awesome. So let's talk a little bit on the non-technical side. Venus, would you be able to speak a little bit about what you guys have been doing to establish your team's presence in your community?
Yeah, so media and branding was one of our main focuses this year, exactly for that reason. It kind of kicked off at Comcast Bootcamp when I attended a media roundtable. Shout out to Miss Daisy. They really inspired us during that roundtable, and we learned a lot through that session. We focused a lot on our consistency because we learned that the more consistent we are, the more recognizable we became in our school community and in the first community. We made a style guide and we kept the same logo that we had the year before to help with that and to increase our visibility. We also made a new website. Our old website was, well, old and outdated and nobody really knew about it. So we made a new one that is now regularly updated and looks a lot nicer. We also increased the amount of pictures and videos you were taking. During meetings, we took pictures and videos on a phone camera as well as on a Canon camera. During Hatbro, we made it our mission to get good media content. During matches, I would take videos on my phone. Another member of our team would take pictures with a camera. One match, I would focus on taking videos of the robot and he would take pictures of our drive team, and then we would switch the next match. We also interviewed members during our competition and overall had a great time documenting it. One of our biggest challenges was definitely not having enough people on our sub team. Since we are kind of a smaller team, building the robot is the priority. Also, just not knowing what we needed to be successful, as it was the first time we put this big of a focus on our media content. We are proud that we were successfully consistent throughout our season, and the interactions that we had through our school, through social media, was something that we found invaluable.
As someone with a background and a career in marketing and social, I love hearing when teams think about this stuff. So props. I'm very excited to check all of this out. Now, of course, 423, one of the teams who were able to compete this season. So, of course, what we've been asking all of our teams that have competed for Infinite Recharge. What did you guys learn? What was the experience of competition? What are you taking back with you for this future version of the season?
Yeah, so we were very lucky to compete at all. All of our teams always helped us out by lending tools and vice versa, and that created a very lively atmosphere.
This year, we tried a shifting gearbox instead of one with just one speed to allow us to have a low gear for precise movements and a high gear to get across the field quickly. We really like the low gear and believe that next year we will reduce it even further for more control. Also this year, we tried a lift unlike anything we've done before, and it also worked very well, even though it had little testing. And even though we had to reduce from two to one separate lifts to save some weight. Finally, we built an intake very late in the season to pick up balls more efficiently, and we were pleasantly surprised when it worked well. Sadly, we did not think about how hard it would be to aim the shooter with the electronics panel in the way, so a lot of our high goal shots ended up going over the goal and past the opposite driver stations. In matches, we learned very quickly what strategy worked best for us. Because our shooter was inconsistent, we decided to attempt a shot and then drop the rest of our power cells so our teammates could grab them. And then we would play defense on shooting robots, and finally make sure we would climb because it was one thing we were very good at and it got us a lot of points.
Our lowest moments were during the eliminations when our climb didn't work efficiently because our drive motor mount kept bending the screws that were holding it on. So we decided to design a new motor mount to keep our attention on that chain and not destroy those screws. And we are sad that we weren't able to design and actually implement it onto the robot this year, and I hope to see that next year. And some of our highest moments was our climb working consistently throughout those qualification matches where they did work, and being chosen in an alliance during quarterfinals, which I would like to thank the teams 62-26 and 12-18 for that opportunity.
Overall, our proudest moment from Hapro was seeing a lot of elements of their robot working well with little testing, successfully climbing 10 times out of 15 matches, having one of the highest total endgame points, and as Ryan said before, going to the quarterfinals with teams 62-26 and 12-18.
So let me ask you guys this very general question. What were you guys most proud of?
This year, I was definitely most proud of our media team and having as many underclassmen on our team as we did this year compared to previous years.
I was most proud of our team's growth because I feel like so many students got involved and learned a lot, so we'll be very prepared for next year. Also, I was very proud of the intake I designed and fabricated because I'd never taken on a responsibility like that, and it ended up working very well with little testing.
I was proud about seeing the lift mechanism work and work consistently. I felt really proud about seeing something that I had drafted and built become very successful in competition.
I'm most proud of our bogey since I've been working on the design for 2 years now, and how sturdy and reliable they were during our competition season. And I do believe that this design will live on throughout several more years of team's history.
I'm really proud of the independence of our student leaders as engineers and fabricators and peer mentors. It's awesome to hand them real raw materials and get back parts. It's also inspiring to watch them teach other students as they go about their work.
I know one of my favorite things about mentoring is being able to sit back and watch my students lead in a way that is empowering to them and makes them really feel like you said, accountable to that project and be able to accomplish something. What else about the Team 423 experience is different?
All right, Libby. So riffing off what you were talking about is the role of the mentors. One of the things that's a little different on our team is that, mentors and students are peers. And this came from a speech Dean gave 20 years ago when he and Woody actually went to all 5, regional competitions. But one of the things the dean had said was that he did never envision this to be a 100% student-driven project. He very much wanted mentors of all kinds working hand in hand with the students and everybody putting in their best efforts. And this leads to a really unique relationship between mentors and students. We're not parents, we're not teachers. And by the time our students, get to the point where they're applying for colleges, I will have spent several hundred hours with them and really get to know them. And just about every student on this call, I've actually personally written a letter of recommendation, and it is by far my favorite part about being able to do this. Is I get to be a mentor and I get to help these students out, and I'm just so excited for their success and their scholarships and getting into college. It's really it's more than just robots, and it really allows us to be more than just what it is about building and engineering students. It's outside support as well. So it's a very cool relationship.
Awesome. Well, it was great hearing from Team 423 Simple Machines tonight. Sounds like they have a very interesting team dynamic and a cultural aspect to their team, which makes them very unique. So Venus, one last question for you guys before we close out. And that is, if we want to learn more about Team 423 Simple Machines, where can we go to learn more?
You guys can check out our website and our social media. We try to connect to teams through that. Also, a huge thanks to all of our sponsors. We wouldn't be here without you guys. And a huge thank you to Cheltenham School District as well for supporting us through our season and for the hard work they're doing to support all students during these times. Shout out to all of our seniors, Ryan, Kai, Colby, and Andrew, for being awesome during this crazy time. And shout out to all of our parents for all of the dinners during this build season. And thank you to FMA, you guys, for having us here and talk about our team.
We are super happy to have you, Team 423 Simple Machines. We appreciate your time so much. Thank you for joining us tonight. We're here with Team 2600 Team Falcon from Oak Ridge, New Jersey. I've got students Jenna and Joey, as well as mentors Mrs. Sawicki and Mr. Nick. So Jenna and Joey, why don't you introduce us to your team?
Hi, I'm Jenna. I'm a junior this year. I've been on the team for 2 years, and it's been very eye-opening about just learning about everything that goes on in robotics, because I was very, very new when I first started.
Hi, I'm Joseph. This year I am a sophomore, and when I joined robotics, I didn't know what I was doing, and then at first I just got right into it, and then I knew what I was doing. I was the first sophomore to be on the drive team as well.
Yeah. So Joseph, let me ask you, looking at our notes here, it looks like there's a particular challenge that you had to go through when you joined the team. Maybe you could tell us a little bit about that. I'm curious to hear the story.
So I had a surgery, and where I couldn't do any heavy lifting, so I wasn't allowed to do anything, and I got yelled at when I was tried to do heavy lifting. So what I wanted to do is I learned Photoshop to make a sticker that we were going to put on the robot. The sticker was called Falcon X because it's our 10th robot.
I love it. I think one of the really interesting things is obviously first teams are so multifaceted. There's so many things that can go on at once around a team. And I love that, even if there was a physical challenge at a certain part of the year, you got onto the media and the art side. So let's dive a little bit into this year's robot and your challenge. What's different about the systems that you guys developed this year?
Our robot is different because it is completely student built, like some other teams where their robots are built by the mentors. So ours is completely student built and programmed. Time management was something that we had to work on, and also figuring out a design that everyone can agree on.
Cool. So Jenna, maybe you can talk a little bit more about mentor involvement. How do the mentors integrate themselves into your team's processes specifically?
So, like Joey said, our team is all student built and programmed, which means our mentors are only there to really guide us and point us in the right direction. It's really the students who take charge and create a plan that they know they can complete on time for the competition. It gives our students a chance to grow with the team. So one of the things that we did is the angles that were needed for the ball shooter. We couldn't really get it right at first, and it took a lot of time with measurements and like making sure all the math was right. And that's something the mentors helped us with because it was a little difficult for us.
I always love hearing about the balance between different teams and their learning process. So what were some challenges you guys had to overcome this year?
Well, one challenge is our soldering skills needed work. Our motor wires, they're very soft wires that are hard to twist together. So it takes a lot of time to really make sure they're together, and it takes a lot of metal to really solder them together. And we didn't get that at first. So it took us a couple tries where the wires kept breaking apart. So it took us a long time to do that, and we had to kind of figure out a trick to do it where we just like really pile on some metal and twist them together really tight. So that took us some time that we could have been testing, which is a challenge we had to overcome.
Yeah, that's one of the perennial situations that you run into in build season. Not so much the soldering specifically, but you look at something simple like, all right, yeah, we're just going to solder the motors together, and that looks on paper like it's going to be a simple process. We all know what we're doing. We're going to move through it, and then you realize it's not working, and you are tasked right away with a high pressure situation where you need to figure out how to make that situation work, or you're going to be behind schedule or further behind schedule or miss your deadlines or whatever it is. And I think a lot of those situations yield the most exciting results, and that's something, maybe it's trivial to think of soldering in terms of everything that a team can do, but that's something it sounds like you guys will remember, at least overcoming a challenge. So speaking of challenges, Joey, maybe you could tell us a little bit about a challenge you had with the intake this year.
So for the intake, we wanted to decide on one, which at first, when we started building, we should have figured out the design first and then start building. But we just started building, and then as we were in the middle of building, we were deciding on a design for the intake. And a couple of people wanted one design, and a couple of people wanted another design. So we had to decide on one. And when we decided on it, there were so many trials and errors with it where it was weighing down too much, or where we welded it wasn't welded too much, or or the intake was too fast, or it was too slow.
It seems like you guys have sort of a different approach to how your team is structured. Jenna, what about the overall sort of size of the team and budget? What challenges does that present?
Team 2600 is a smaller size team with few members and a small budget, which makes our team very resourceful and able to think on their feet. We have to find parts that will work for our ideas that year. We've had to repurpose old robots for parts, which helps reduce our team's carbon footprint and saves on waste that could come from our robots. And even sometimes we use old designs and ideas when the challenges are similar to ones that we have now. We can still use past knowledge from teams that we were on and teams before us to really figure out the best robot for the challenge.
So what about the weight limit in terms of the robot in its final form?
Usually our robots aren't super heavy, but this year we chose to go with a welded piece on top to the ball shooter and holder, which was made out of steel, so it was really heavy. And it weighed down our robot, so we had to really make some compromises with it. So we kept that, but we had to take out some extra parts that we didn't really need.
What were the sort of iterations on that ball holder design?
One of our designs we wanted was like, it was going to be like a circle, and the shooting mechanism was going to be kind of like a turret where it would turn 360. But then we decided on we would have plastic velcroed, so it was kind of like almost like a conveyor belt. And then we would have a motor where the steel welded was, we would have it welded on there, and the motor would bring it up over onto the top, and then to the top where it would shoot out. And we had it velcroed because the previous year we didn't have like stuff that accessible. So this year we wanted to have it accessible. So if we had to work on something while we were in the pit, if we had a competition, we could just take it apart easily and work on it and put it back together.
So you guys move into actually testing and troubleshooting and stress testing the design. Jenna, maybe you could talk a little bit about that.
Well, that last design Joey talked about with the conveyor belt style, when we were testing it, we had the motor running for a really long time, and it kind of came like not super loose, but it was not in the same spot that it was before. During stress testing, we learned that it really wasn't as strong as it really needed to be to hold up during a competition. So we created a whole new design. We just scrapped it all and we're like, we have to figure out something else to make sure that this never breaks on us, which is why we went with a whole welded frame.
Yeah, durability is super important in FRC, right? It can make or break that competition experience. So I'd love to hear a little bit more about your manufacturing, Joey.
For the ball intake, we made it out of aluminum square stock, and the holder out of steel square tubing, which was where we welded. Which one of our other mentors actually taught us how to weld that part, so we actually learned some welding, which is actually really fun to do.
Jenna, is that something you guys have always had the capability to do, to weld parts like that?
No, not really. This is why we're talking about it so much, so excited about it, because before the team didn't really have a mentor who knew how to weld or had a welder that we were allowed to use, because we used our mentor's welder, and he's the one who taught us, and it's not a skill that many of us had. So it was really awesome for us to get to learn that, and we were very excited about it.
I think one of the most unique things about the FRC experience, like you said, is working with mentors to learn a new skill or a new sort of component in your education that you might not be having in the classroom. Now, I'm seeing something here about sort of like integrating some math in here as well. So Joey, maybe you'd like to expand on that.
When we wanted to get the angle for the shooting mechanism, we had to test many angles, and we actually did have to use math. So say like at a certain distance, and then we had to figure out the angle and the speed of the motor that we wanted to shoot. So it would hit the target. We also took the measurements so our ball would fit in the system of the intake and the shooting. And with the measurements, we had to make sure we still had enough room for like the components, like the motors, the Robo Rio. And at one point, we had to move the battery box to one side so we can fit the whole shooting mechanism in the back. By creating the new ball system, our robot would be more reliable, and the team could have a better chance of scoring points and be able to compete better.
Let's talk about some of the goals. What were some of the objectives that your team set your sights on for this year?
Because we're really a student team, we have to pick a few goals that we know we can complete by the time it's time to go to competition. So one of them that we picked was we wanted to have 3 balls in the holder when we started each match. So then we'd know that we had enough balls that we could start shooting, so we wouldn't have to go and pick up balls right away. This seems like a very achievable goal to start with 3 balls, but when we started making the holder, we had to make room for other things like wiring and the Robo Rio, like Joey said. So we couldn't make the ball holder that big to be able to hold 3 balls just on its own. So we had to cut it down to 2 for that design with the conveyor belt. But once we scrapped that design and we started this other welded one, it was actually elevated above the ground of the robot, or the floor of the robot. So we could have all that wiring and the Robo Rio and everything on the floor and have that elevated up so we could hold 3 balls and we could make it bigger and still have enough room for everything.
I really love the idea of hearing about other teams' sort of iteration process. And when we tried this and it didn't work, and we tried that and we needed to adjust it. I'd love to hear a little bit about material selection from you guys too.
Because we started with the plastic and it was an aluminum and plastic together with Velcro, it didn't hold up the way we wanted to. So we learned the importance of actually picking the right materials because we moved to steel, which is much stronger, and it was able to really be welded together and not come apart under stress. And it's really a life lesson because that goes with everything. If you're going to build something like a building or a bridge, you need to know the right materials so it holds up over time.
Nice. Yeah, it's cool. I applaud you as a student on a team, able to recognize some of the life lessons that FRC can offer you. I think that's what makes it really valuable. You can apply that in your real world situations and in your careers as you move on and past FRC. So that's great, Jen. I'm glad to hear it. Joey, let me ask you, what's something that you're super proud of in regards to what the team's done?
I'm most proud of how hard our how hard the team worked because without many members, each person had to do more. They all had to take on more responsibility. So like some of us had to take on like multiple roles.
Yeah, I know Jeff and I have both had lots of FRC experience, and I think we've both been on big teams and small teams, and depending on the size of the team and the group of people, everyone's got to wear multiple hats, and it's really cool to hear that you guys are sort of taking that responsibility on. Jenna, what about you? What are you sort of most proud of or taking away from your FRC experience?
FRC has really helped me learn how to be on a team, how to learn how to take responsibility for a section of the team and take charge and get my ideas out there while also listening to other people's.
Awesome. So, Joey, is there anything else about Team 2600 that you'd like to tell us?
I would like to take the time to thank our sponsors, Ben Schaffer Recreation, FES East LLC, Jimmy G's Sports Bar and Grill, Northeast Risk Solutions, Picatinny STEM, and Jefferson Township High School.
Awesome. Of course, we always love our sponsors, folks who keep teams running. Jenna, if I want to learn more about Team 2600, where can I find you guys online?
You can go to Instagram at jths_tech_ed.
Wonderful. Well, thank you guys so much for joining us tonight.
Cool. So we're here with Team 303, the test team out of Bridgewater, New Jersey. I'm here with student representatives Nick, Natasha, and Vishnu, as well as their mentor, Mrs. Nason. So with that, I'm going to hand it off to you guys. Why don't you introduce us to Team 303?
Hey everybody, my name is Nick, and I'm currently a senior on Team 303. This year I was one of our project managers on the team, and I was also the driver for our robot.
Hi, my name is Vishnu. I'm a junior on the team this year, and I was the lead programmer and the operator on the drive team.
Hi everyone, my name is Natasha. I'm also a junior on the team. I was one of the project managers this year, and I was also the human player for our drive team. Today, we are going to talk a little bit about our robot design and how our shortened season went.
Very cool. Well, it's nice to meet you all. Why don't you get us started with a little bit of your 2020 robot design?
Sure. So when coming up with a plan for our robot design, we like to gather for a group discussion, and we like to go over all the rules and misconceptions that people may have. And we use that to then come up with a priority list of tasks that we think that our robot should be able to complete. So once we have this priority list, we then split the team up into different prototyping groups for each of the different subsystems that we intend to have on our robot. For this year, for example, we split up into like a drive-based team, a shooter team, a climber team, an intake team, and a control panel team, so they could all work together efficiently. We encourage our prototyping groups to come up with a bunch of different designs for each of these ideas so that we can test out multiple designs and see what works for each subsystem. Once we have identified the best design for each mechanism, we then move to converting each mechanism into an electronic design in SolidWorks, and then we move on to integrating them into a final robot design. Once the design is complete, we can then move on to manufacturing and assembly. As far as our actual design goes for this season, we took a lot of inspiration from successful robots that completed in games like Stronghold, Recycle Rush, and Aim High. We knew that we wanted our robot to be able to be capable of loading power cells from the floor, shooting them into the high goal, climbing on the shield generator, and spinning the control panel. In our design, we wanted to prioritize short cycle times through the trench run, as the safe zone in the trench run would provide protection from defense. This meant that we had to design our robot with the capability of fitting underneath the trench run. We'd also planned on shooting power cells from different spots within the trench run to mitigate the effects of defense on our scoring effectiveness. For this year, our drive base was an 8-wheel West Coast drive with 6-inch VexPro traction wheels built on a 1x3-inch extruded aluminum box. It has a 1/16 inch drop center to reduce the amount of side scrub and to allow the robot to more easily navigate the shield generator in the middle of the field. Our drive base is powered by 6 Falcon 500 motors and is able to travel at around 11 feet per second. Our electronics are mounted upside down on a dorsal pan so that they are more easily accessible and serviceable. This dorsal pan also serves to make the drive base itself more rigid. The intake on our robot deploys out over the bumper with 2 pneumatic cylinders. It uses 3 polycarbonate rollers that are linked together with a number 25 chain to suck up the power cells up and over the bumper into our indexer system. The intake on our robot is powered by a single Neo 550 motor. The indexer system receives the power cells through the intake mechanism and stores them in an open top hopper. There are a series of custom 3D printed pulleys on the floor of the hopper that have polycord running on them to feed the power cells backward toward the shooter. The polycord system is also powered by a single Neo 550 motor. The open top hopper also allows us to pick up power cells from the ground as we originally planned, as well as from the human player loading station. Once the power cells are loaded back into the indexer, they move on to the shooter, which is a fixed angle single wheel hooded shooter, which uses four 4-inch Coulsons to propel the power cells. It is powered by two Rev Neo motors, and in addition to this, it also has two custom steel flywheels to gain more rotational inertia. This has allowed the shooter to run at a very consistent rotational speed, even when shooting out the 5 power cells that we have stored. Our climber uses a similar design to the elevators that we have created in the past 2 seasons of FRC. It's a custom single-stage elevator made using 1x1-inch extruded aluminum box, and it's powered by two Rev Neo motors. The design uses a constant force spring to shuttle the carriage up and two AM steel ropes wound around a hex shaft to pull the carriage back down once the climber is hooked onto the shield generator switch. Because we had set out to fit underneath the trench run, it would have been impossible to store this elevator designed vertically, as it would have been too tall. Because of this, we had to articulate the entire climber subsystem. The lift is stored diagonally and it's retracted straight throughout the match, and it uses two pneumatic cylinders to extend the climber into a vertical position when the robot is ready to climb. Additionally, we have a secondary fold-out hook, which extends when the lift is raised up so that the robot is able to reach the rung more easily. Our control panel mechanism is an anti-mark green compliant wheel powered by a Neo 550 with a color sensor mounted to the bottom of it. It's easily integrated into our climber mechanism as the climber was already actuating up and down during the match, so it was easy enough just to mount the control panel motor onto the side of our elevator.
Nice. Yeah, it sounds like you guys had some pretty creative approaches to the challenge of packaging a robot together in this game that has all of that functionality. And it looks like you guys did a great job. Vishnu, maybe you can run us through some of the background on the programming and software that runs this robot.
Yeah, so our team accomplished a lot in terms of programming this year, but the aspect we were really most proud of is the autonomous capabilities. So we implemented some different functionalities in our autonomous code. We used the limelight to turn to face the power port as long as the limelight could view it. And we not only use this during the autonomous period, but we also use this during teleop to aid the driver. We also implemented Pathfinder and trajectories to be able to follow different paths that we wanted it to follow during autonomous. Because the season was cut short, we were unable to polish some of the functionalities and in some cases even try some out. So for example, we were in the process of writing a program to detect the closest power cell via vision code and move to it autonomously. Although it wasn't as smooth as we wanted it to be, it did work and it gave us a good understanding of what could be improved. During the Hapro event, we had an indexer mechanism which we wanted to use a time of flight sensor with in order to autonomously line up, space out, and get a power cell ready to be shot based on how many power cells were in the indexer. Another cool ability that we had working but wanted to polish was having our shooter adjust its velocity based on the distance. We used our camera and trigonometry to calculate the distance from the power port. We would then use an algorithm using values we had tested to find the ideal velocity for a given distance. One thing we were working on and were close to finishing before Hapro was an 8-cell auto. The idea was to start with 3 power cells, shoot those, then pick up 5 power cells from the trench and then shoot those 3. But overall, we were pretty proud of what we accomplished in programming this year, and we're definitely excited to keep extending on those ideas.
Well, thank you so much for the deep dive. I always love hearing about other teams' robots. It's part of the reason we do this. And I've definitely loved to get a look at the 303 machine. Now, you guys got to compete at the Hapro Horsham District event. Why don't you shed a little light on that experience for us?
Yeah, so our team had a very interesting experience at Hapro. So before one of our matches, we had disabled the vision targeting light in order to work on the robot. However, we forgot to turn the light back on before the match. So when our autonomous code ran, the vision code was not able to align with the power port without the light being on. So we ended up shooting the power cells into the stands. It was a learning experience, though. During another match, we decided to rotate the control panel before stage 2, but we like to say that this was on purpose. So we decided to rotate the control panel in order to showcase our robot's functionality. But overall, our experience at Hapro was great. Everyone on the team had a great time and was very excited to see the robot we had been working on for weeks finally pay off and compete. We are very thankful that we had the opportunity to compete this season.
Nice. Yeah, it sounds like Hapro was a fun time for you guys. And I can appreciate that you looked at the challenges as learning opportunities. So with that being said, what kind of lessons have you learned from Hapro? And more specifically, what areas would you like to improve, after getting the opportunity to compete?
Yeah, so certainly Hapro provided a lot of things that we would like to improve on. So after competing at Hapro, we had a better idea of what worked and what didn't for the robot for this specific game. We originally had a different design for our intake and indexer mechanism, which used a time of flight sensor to count and space out the power cells within the robot. But we found that the system was super clunky and inefficient, so we set out to redesign both the intake and indexer for the Mount Olive event the following weekend. What resulted was our current intake and indexer design, which we affectionately call our intake in 2 days, as it was designed and built in just 2 build meetings. It used parts of the old indexer and an entirely new intake mechanism and hopper system, and it functions much better than the previous design.
In terms of programming, competing at Hapro definitely taught us a lot. So going forward for next season, we would like to improve our robot in a few ways. We need to more effectively tune our intake and indexer to make sure that power cells flow smoothly throughout the robot. We want to continue to tune the shooter for different velocities from different locations. It worked best in the front part of the trench, but we were on the way to tuning it, and it would have been great if we could get it perfect. We would also like to spend more time developing our autonomous routines, as we never got a lot of time on the practice field dedicated to writing autonomous code. In the future, we will prioritize faster power cell pickup and faster shooting to maximize the points we can score during autonomous.
I think one of the most valuable things about teams that have already competed in the Infinite Recharge season, the things that they can bring back to us in the community are those on-field experiences and the learning process that comes from competing on-field. Now, you guys also won the Engineering Inspiration Award at that event. Congratulations. Natasha, I'd love to hear a little bit about what you guys do in your community. It's obviously something to be very proud of.
Yes, so this year at Hapro, we were lucky to be the only district winners of the Engineering Inspiration Award. We really tried to focus our team in starting and expanding the network of first teams in our school district. So last year we started our FLL Junior Initiative and created and mentored 6 FLL Junior teams in 2 of the elementary schools in our district. And this year we even expanded further upon that to create 9 teams across 4 elementary schools in our district. The members of our team would act as mentors to these teams and guide the students through the season. Along with our FLL Junior teams, this year Team 303 also created 3 FTC teams in our local middle school. We really hope to start a first team in every school in the district in order to provide students access to first programs throughout their entire education. In addition to that, we also started the I Am Valid initiative. Last year, unfortunately, we lost an alumni of our team who had been battling mental health problems for a long time. Charlie was a prominent member of our team, a member of our drive team, and always very enthusiastic. One of the main values he tried to instill in everyone is that everyone should be accepted for who they are as they are. And since the theme this year was First Rise, we wanted to encourage the first community to rise to the challenge and really accept everyone for who they are. And thus the I Am Valid initiative was born. We created buttons with this hashtag and a poster to hang it in our pit, advocating for everybody to be accepted as who they are. We passed out these buttons to the members of our own team as well as other teams. We are very happy that our initiative even reached a judge advisor in South California. He asked us to ship us some of our buttons so that he could continue to spread the message of inclusivity. Even after quarantine ends, we are willing to ship buttons to anyone who would like so that we can all feel valid together and continue to spread this message.
Wow, that's awesome. Yeah, that's a very a beautiful initiative, and my hat is off to you guys for launching such an important message into the FRC community and the community in general. Right. So with that being said, one last question for you guys. If we want to learn more about 303 as an organization and as a team, where can we go to learn more?
Well, you can check us out at our website, team303.com. We also have a Twitter, Instagram, and Facebook at FRC Team 303. Please follow and you can keep up with us on there. We also have a YouTube, so you guys can check us out there, see our robot, and everything that we do as a team.
Awesome. Well, thank you guys so much for joining us tonight. We love hearing your stories, and we will see you soon.
Awesome. Yeah. And one last Q&A session lined up right after this. So don't leave just yet. We'll be with you in just a moment.
All right, we are here for our final Q&A of the season. Jeff, who do we have here with us?
Yeah, absolutely. So we're here tonight with Nick, Vishnu, and Natasha, and they're accompanied by their mentor, Mrs. Nason from Team 303, who we just heard from in the last segment. So we're going to jump right into some questions with them. Remember, everybody who's watching at home, to keep posting your questions to the chat, because we will be picking them out and trying to ask them to Team 303 during this live segment. So with that, Libby, I hand it off to you. Why don't you ask them the first question?
Of course. So, of course, we just finished watching your segment. And, of course, you closed out with your I Am Valid campaign. And the chat wants to know, and I want to know as well, how do I get one of these buttons?
You guys are all welcome to send us an email or visit our website through there. And I guess once quarantine is over, we can mail you guys a button.
Nice. Yeah. Super awesome campaign, and definitely something that sounds like it'll have legs for years to come. So next question for you guys, a little bit more on the technical side. You guys did mention in your segment that you drew a lot of inspiration from robots, specifically competing in the 2006, 2015, and 2016 seasons. Are there any specific teams or robots that you want to shout out for inspiring a particular subsystem or design? Any real gems that you guys really appreciated and drew a lot of inspiration from?
I think that we didn't really take any specific inspiration from any one singular robot. A lot of it was more analyzing the strategy of how the game was played in each of those other seasons, especially in 2006. It was really focused on shooting a lot of balls in a quick succession. So I think that that's what we really tried to focus on, and looking at a bunch of different robots from that season. And also in the 2012 season, a lot of the ball intakes for the basketball game, those were really quite similar, especially with the ball size was very similar to the power cells for this game. So we tried to look at a bunch of different designs and sort of familiarize ourselves with how teams decided to design for those seasons so we could influence our designs for this year.
I think that's really important, right? You know, when you talk about FRC concept design, there's tons and tons of ways to pick up a ball off the carpet or put a ball in the goal at a similar distance. And I think the careful study of how that worked in previous games, not the copying, but sort of the idea of match flow and how things are accomplished is really important, so that it's almost like, you know, you save yourself step one of prototyping and you can see the different concepts out there. So it's really smart. Definitely something I encourage to any team who's sort of like, how do I improve my prototyping process? The first step would be to go back towards similar FRC games and see what worked and what didn't, knowing that it might not always be the same thing. So again, sort of diving robot specific here. You mentioned in your segment that you used both Falcon 500s and Neos on the robot. Is there any reason you opted for both brushless motors instead of standardizing for one or the other?
Yeah, I think definitely, especially like from last season and this season, the brushless motors were a huge help to especially saving weight on the robot. And once we saw in the preseason this past year that the Falcon 500s were coming out, we were really excited to get those in hand. But we had sort of an issue with, getting them in and getting enough supply to actually build an entire robot with just Falcon 500s. So we opted to include the Neos that we already had in our shop and also the Falcon 500s that we were able to actually get a hold of. So that's sort of why we had the mix. And also the new Neo 550 motor, which is sort of a smaller form factor motor, was very useful for stuff like the intake and the indexer.
Cool. Yeah, I know. As much as I like the Falcon 500 product, I agree that one of the biggest challenges with using them this year was just getting your hands on some. Everybody wanted them, and they were definitely a hot product to get for this build season. So hopefully they become more available, and we can use them more prevalently if we decide to. So that's awesome. Next question for you guys. Your robot's color coordination game was on point, with lots of 3D printed wheels and rollers in the 303 teal. What printer and filament did you guys use for this?
Oh yeah, so we've actually been using 3D printed stuff on our robots for, I don't know, like 6 years now. We have both a MakerBot and Ultimaker 3D printer that we have. All of those parts were printed on the Ultimaker 2 Plus, which is a very reliable 3D printer that prints, we mostly printed in PLA. So that's just 3mm teal PLA filament, and pretty much works for everything you throw at it. You can, as long as the part is 3D printable, it pretty much will work on the robot, as long as it's not seeing too much load. But stuff like those pulleys and other small things that are not really seeing too much forces, it's really helpful to get a custom size and shape on parts that you wouldn't be able to machine as easily.
Yeah. So I'm always interested in 3D printing processes because it's something that we do a lot of on my team, but it's always through a sponsor of like design part and hand to and then get back, right? So I'm super curious when other teams sort of dive into that process. We just don't happen to have any that are like our teams and our own, so that's super fascinating. A question / comment from the chat is, were all of those, so in your segment you displayed a lot of your shop and your practice space, were those all your old robots in your shop? The comment is that it's so cool, but I'd love to hear a little bit about your decoration and who's around in your shop space as far as old robots go.
Yeah, so we actually have sort of all of our robots that have ever been made by 303 just on these wooden platforms in the side of our shop. And this is actually really helpful for, for example, like in 2018 Power Up, we were actually able to pull down our robot from 2011 and look at how they designed the elevator for that year and how they designed the game pickup mechanisms. So it's pretty cool to see, like, you may not be able to talk to the students from the past, but you can see the mechanisms and robots that they've actually created, so you can kind of indirectly interact with them.
Yeah, I imagine it's highly inspirational to see, this multi-generational progression of robots, right? I think too, it probably doesn't hurt on the recruiting front either if you have a nice showcase of quality machines to show off too. So I'm sure there's a lot of new recruits that are super excited to see that as well. All right, last question it looks like we got for you guys tonight. This is a big one, and I would not be opposed to hearing from each of you on this. There are 3 of you guys on the call right now. And again, I'm not surprised, or I wouldn't be surprised if you hadn't particularly talked about this yet, but I'd love to hear your perspective. What type of changes are you planning on making, or would you like to make for the Infinite Replay 2021 season? So any specific upgrades, modifications, changes that you'd like to make to your robot for that season?
Yeah, so I'll talk about specifically for mechanically. We're already in the process of revamping our robot design when the season got kind of suddenly canceled. So definitely we're working on improving our intake and hopper systems, sort of work more fluidly. That's definitely one of the main issues that we had at Hatboro was our, the power cells weren't really feeding super well. So it's really our main area of focus. A lot of the other stuff on our robot worked very well, especially the drivetrain. That's sort of something we've been working on for past 5 seasons of similar design drivetrains. So yeah, I would think that it's mainly just the hopper system and intake system.
For programming, we really want to focus on 2 main things for fixing it. We want to be able to shoot from different spots on the field. For the most part, we were mostly able to shoot from the front of the trench, but we really want to be able to shoot from all around the field, or at least in our half, just for more versatility. And we also want to improve our autos to maybe shoot a few more power cells, or just run faster in general.
Nice. Natasha, any thoughts?
Yeah, I agree with what Nick and Vishnu said. One of our biggest problems this year was our weight. We were very close to, we were over for a long time, and then we were very close to the weight limit. So I think we want to cut down on how much we weigh, and we've tried to put a lot of our mechanisms in a small amount of space, so that we could fit under the trench. But while doing this, we also used a lot of metal, and we made our robot really heavy. So we'd like to work on maybe different types of materials, or lightening it up a little bit, maybe moving some things around just so that we aren't as heavy.
I feel like we sound like broken records on the FMA Plus channel, but it's going to be, since first announced that we're going to be replaying at least most of the primary elements of the game, it's going to be really interesting to see how teams go down that iteration path. And even specifically on your point of weight reduction for the robot, there are now, as of yesterday, different fabrication rules too. So we'll have to see how those impact potential future designs. However, thank you to the chatters and to our FMA Plus crew. That's going to be it for our questions with Team 303. So we want to give you guys a huge thank you, the test team from Bridgewater, New Jersey, for taking the time to speak with us tonight.
Thank you for having us. I hope you enjoyed our presentation.
Absolutely.
Yeah, it was great. All right, so a little bit of bittersweet news that you guys might all be aware of. As you may know, this is going to be the last episode of FMA Plus for the 2020 year. There are some thoughts about potential projects in the future, but only time will tell. We still have to go to the drawing board on those for sure. This competition season came to an abrupt and unexpected end, as everybody is painfully aware. There are a lot of emotions swirling around out there, and thankfully, a group of FMA members were able to band together to produce something positive out of an otherwise unfortunate situation. Now, Libby and I are obviously parts of that group, but the group is much larger than the two of us. And that group created FMA Plus. They deserve some recognition for the work that they have done. So without further ado, Libby, let's do our roll call. So first off, thank you to Catherine from Team 341 for carrying a significant amount of the load in terms of the editing and post-production process. Catherine, much appreciated for sure. Next, I'd like to thank Ravi, a mentor from Team 219 and 6943. Ravi handled pre-interview support, and he also provided valuable video quality checks. So once the videos came through production, Ravi was one of the people who would give a seal of approval to put it through the final broadcast. Next, we have Sean, a mentor from Team 1712. Sean handled editing as well as managing our live Q&A question queue and monitoring the chat during our live broadcasts. After that, we have Howard, a mentor from Team 25 and 694. Howard was a valuable member of our team, moderating chat and providing those same video quality checks in conjunction with Ravi. So Howard was another one of our white glove check people who would provide valuable feedback on our post-production processes. Next, we have my wife, Katie, mentor from Team 1923. So those of you who were able to join us on an FMA Plus broadcast or as a participating team member probably had a pre-interview with Katie. Katie was charged with managing and leading the pre-interview efforts, as well as providing editing and post-production support. Next, we have Kier. Kier's a mentor from Team 341. Kier, super valuable on our team. She helped to lead the way. She was very good at delegating and keeping everybody organized. She was one of the best editors on our team, I would think. And she also provided valuable team correspondence, as well as those infamous video quality checks. And finally, I want to say thank you to Libby, who is not only serving as my incredibly talented co-host, but also managing final edits, as well as being the general subject matter expert on show production and broadcasting. Thank you to all of you for doing what you do. This was a massive undertaking launched with minimal preparation, but we've all done it. Thank you for donating so much of your time over the past 12 weeks working together to make FMA Plus a reality.
Well, thank you, Jeff. But of course, you forgot one of the crew members. We want to give a big thank you to you, of course, Jeff, a mentor from Team 747 Flight Crew as well, for co-hosting with me, for bringing us all together as a driver behind this show idea, really sort of managing our project and driving us all forward, and for bringing your personality and I'll even appreciate the puns once in a while to FMA Plus. It has been a joy and an honor to work with you. And of course, if you're someone at home, everyone at home watching these broadcasts, whether you're a regular FMA Plus viewer or a first-time audience member tonight, thank you for taking the time to afford these incredible teams from the First Mid-Atlantic region the opportunity to be heard and to show you what they've been working on so hard this past year, even though our season went a little wonky. We know on the FMA Plus crew that the status of things right now is pretty uncertain. We don't yet know how the next school year and the next season are going to turn out. But I know I am, and the rest of us are very much looking forward to seeing all of you at a competition very soon. On behalf of everyone here at FMA Plus, thank you so much for watching. Stay safe. And of course, we'll be in the audience alongside you next week for First Mid-Atlantic's Regional Chairman's Award and Don Bauer's Inspiration Awards show. So same time, same place right here on the channel. We will see you then.